A question is regarding the formation of product from a starting material toluene with a sequence of different varieties of reagents in various steps. And the reaction conditions from the toluene as starting material is given by set of reagents and the corresponding components present in the mid of the transformation from the toluene were asked for us. Toluene is subjected for oxidation with KMnO4 because KMnO4, as we know, it is acting as oxidizing agent. Further, whatever the product is obtained, that is subjected for thionyl chloride reaction, whereas chlorination generally takes place. Further, whatever the product is obtained as B, that was subjected for hydrogenation in presence of hydrogen followed by what? Palladium. Whereas, as we know, this is toluene. Toluene is what? Methyl benzene. Methyl benzene is known as what? Toluene. This toluene is subjected for KMnO4. KMnO4 is strongest oxidizing agent. Whatever the saturated unsaturations are present, at least with one alpha hydrogen, whatever the lengthy chain is there, due to this highest, strongest oxidizing agent presence, that is converted to carboxylic acid, that is benzoic acid formation takes place. This is our A. Here I am writing a square box. Our A is what? Benzoic acid. Whereas this benzoic acid is subjected for thionyl chloride, that is SOCl2. This is thionyl chloride. As being it is thionyl chloride in thionyl chloride, here what happens is this H and Cl elimination takes place first. Thus it results into the formation of, this is benzoyl C double bond O followed by remaining O, S double bond O followed by Cl. Formation takes place intuitively. So there once again this SO2 acting as good leaving group, and chlorine which is present at its terminals is acting as good attacking group. Intramolecular nucleophilic substitution reaction takes place that results into the formation of here COCl, that is benzoyl chloride formation takes place. That is our compound B. Whereas that formed benzoyl chloride, whatever is there, now here that was subjected for the reduction in presence of hydrogen followed by palladium. Hydrogen followed by palladium makes reduction. So therefore this chlorine is got replaced by the hydrogen. This reduction is said to be Rosenmund reduction. Thus it results into the formation of what? Benzaldehyde formation takes place. Once again, the sequence of all varieties of reactions, those are participating from the toluene as starting materials. If we focus once again, toluene on reaction with KMnO4. KMnO4 is one of the strongest oxidizing agent. As a result of its reaction, the methyl group present on the benzene is converted to carboxylic acid. The not only methyls, whatever the lengthy chain alkyl groups of aliphatic, saturated and the unsaturated having at least one alpha hydrogen, everything will be getting converted as one carbon containing acid, that is carboxylic acid. Here also benzoic acid formation takes place. This one on reaction with thionyl chloride, finally it results into what? Benzoyl chloride. This benzoyl chloride on reaction with hydrogen in presence of palladium, reduction takes place. Chlorine is got replaced by the hydrogen, results into the formation of what? Benzaldehyde. This reaction is said to be Rosenmund reduction. The next reaction is related to the electrophilic addition over the unsaturation present over the benzene system, and the reactions corresponding conditions are given by allyl benzene is allowed to react with the HCl. You were asked to write the final product of the transformation. Very interesting reaction. This is allyl benzene. Allyl benzene is having zigzag form of allyl benzene is like this. Whereas on this allyl benzene, HCl offers what? H plus. H plus is what? Electron deficient compound. Whereas benzene is electron rich, but this is present as a part and part of. Usually students always faces a doubt why benzene is not participating in addition with the hydrogen actively, why only the terminal bond participates. Because these three bonds combination offers extra stability, that is known as aromatic nature. Due to this aromatic nature, it doesn't make an attack with the H plus. So therefore this isolated double bond, which is not a part and part of this aromaticity, participate in addition. This is acting as electron rich species. This is acting as electron deficient species. So therefore, it makes an attack over the vacant orbital present over the hydrogen. We symbolically represent like this. But here there are two chances. H can be connected here. That will generate secondary carbocation, which is found to be relatively more stable. And here if H is connected here, it will generate primary carbocation, which is relatively less stable. So therefore, more stable is comes with higher in percentage. Hence the product formed, otherwise intermediate formed in this case of reaction is H attacks from the terminal. As a result, this particular one becomes carbocation, that is secondary carbocation formation takes place. To this secondary, there is an adjacent carbon which is also secondary, but this is what? Benzylic carbon. Benzylic carbon is more stable because it can involve in resonance. For this only hyperconjugation is there, but for this hyperconjugations followed by resonance is possible. Due to that reason, here what happens is, out of the two hydrogens, one hydrogen as hydride ion transfers to this. This is secondary, this is not OH. Yes, one hydrogen as hydride ion transfers to the formed secondary carbocation to convert to stablest carbocation. Thus the final cation formed in this transformation is, now here this is the place where hydrogens are present. Now this became what? Carbocation. On this, the nucleophile, that is Cl minus, makes a nucleophilic attack over this because it is stablest part, because it is having hyperconjugations, it is having mesomeric effects, it is present as a part and part of resonance. Here Cl makes an attack. Thus, as a result of attack of Cl as nucleophile over this, it results into the formation of 1-chloro, that is, we can say it as what? 1-chloro 1-phenyl ethane formation. 1-chloro 1-phenyl propane formation takes place. It is not the place where Cl is connected over the double bond. HCl is not connected over the double bond. It is not a regio-specific. It is not the regio-specific. It participates in others part. So therefore, chlorine attack takes place on the carbon having stablest cation presence is present. That cation is formed under resonance. After the resonance, the formed stablest carbocation is being attacked by the Cl minus nucleophile, result into the formation of 1-phenyl 1-chloro propane formation takes place. 1-phenyl 1-chloro, if I give the numbering 1, 2, 3, 1-phenyl 1-chloro 1-phenyl 1-chloro propane formation takes place.